in my screen. All right, so ideal gas law. This is the big one. This is going to be our mathematical relationship flow equation. And it's going to relate all four things that you can measure about a gas. So far with Boyles and Charles and Gay-Lussac's, we were really looking at, I have pressure and volume, I change one of them, what happens to the other? So we were looking at two variables at a time. Charles, we looked at volume and temperature. Gay-Lussac's, we looked at pressure and temperature. This gas law, instead of having like the before and after, all we're going to have is each of the things we can measure. So in the lab, like tomorrow, you're going to calculate the pressure inside a popcorn kernel before it pops. So we'll measure volume, we'll measure moles, we'll measure temperature, and you will calculate pressure. Next week, one day, we will measure pressure and temperature and volume, and you'll calculate moles. Right? So like if you know three of them from measuring in a lab, you can determine the fourth. So this is what the equation looks like. It's on the back of your periodic table. So again, we're not memorizing things, but the equation is P times V equals N times R times T. And chemists read this as the PIV-NERT equation. They read it as a word, so PIV-NERT. And I think you probably know what most of the letters stand for. What does the P stand for? Pressure. Now, technically, your pressure could be in any pressure unit. But for us, because we're going to have a constant in this equation, and like that number varies based on pressure. To make this nice, our pressures will either be ATM or mmHg. I won't give any other pressure units for this particular equation. So our pressures will either be in ATMs or mmHg. Those are the two big ones for chemistry. Yeah. You probably know the letter V stands for. But you won't say it because you're quiet. Fine. So V is volume. Now, the last 2 days, when we did the volumes, it was a V on both sides of the equation. So as long as they were in the same unit, it was fine. This equation is going to require very specific units for things. So for this particular equation, your volume has to be liters. No other choices. Okay? So when you plug the number into the equation, your volume has to be measured in liters. In labs, liters is a lot of gas to collect. Like if I made you collect liters of butane next Monday, like it would be kind of annoying, right? So typically in a lab setting, measurement-wise, we are going to have milliliters. So make sure if I give you milliliters, you divide it by 1,000 to get the liters. And you never have to show me that. You can just figure it out. But it has to be liters when you plug it into this equation. We'll skip the next two. We'll do T. What does T represent? Temperature. We've already had this issue, but what unit does temperature absolutely have to be in? What unit have we been using the last day, yesterday? Kelvin. Absolutely, when you plug the number in, you have to plug in Kelvin. And again, you're going to have the same issue where when we measure in a lab, there aren't thermometers that measure in Kelvin. We always measure in Celsius. So you're going to have to take your Celsius and turn it into Kelvin before you can use this equation. And I'm thinking you already remember that, but it is your Celsius plus 273.15. All right, so you have to do this. All right, so it has to be liters, has to be Kelvin. The N in the equation stands for number of moles. So that's the fourth thing that we can measure about a gas. So pressure, volume, temperature, and now we're going to add in moles. They don't use the letter M because M stands for mass, and moles and mass relate. So they chose the letter N. So I always write number of moles to help you remember that that's what the N stands for. And again, when you plug a number in, it has to be moles, all right? Can't plug anything else in for N. It has to be a mole number. But in a lab, can we measure in moles? No, what do we measure in? Grams. So in some of these problems, you're gonna have to do some conversions between grams and moles to make sure that you're plugging in moles, or when you solve for N, it's gonna be moles and you might have to turn that into grams. Okay? So just realize that this equation has very specific units. R is gonna be a constant, all right? So constants are things that don't change. Except that R has lots of different values, and the values are all different depending on what pressure unit you are in. And this is why our pressures will either be ATM or MMHG. I'm not going to do all of them because I wasn't going to type all of the R's onto the back of your periodic table. But it is a constant. So when we, bless you, get to problems, R has only two options for you. All right, there's two on the back of your periodic table. You just have to make sure you pick the right one. If our pressure is in atmospheres, so ATM, for R, we plug in 0.08206. Don't have to memorize it. It is on the back of your periodic table, right underneath this equation. But that's what R is always going to be if your pressure is in ATM. It gets really funny units. Its units are a combination of all of the other ones. R is the one time I won't make you write the units with it. If you don't want to write the annoying units, it's fine. Just put 0.08206 and we're cool. But that is the constant is the reason why you have to be in liters, you have to be in moles, and you have to be in Kelvin. It's because of the constants units. And then your other option for R, if your pressure is in millimeters of mercury, is 62.36. And that's if it's millimeters of mercury. And honestly, it's kind of like every other problem in this unit so far. Read the problem, figure out what letters you have, plug in the ones you have, solve for the one you don't, all right? And I would, again, encourage you as you're reading to label things. That's what I'm going to do. I'm going to model it for you. Just to make sure you're like getting the right numbers in the right spot. And then you have to do a unit check on this one. You always have to check, are my numbers or my measurements in the right units for this particular equation. So we'll do two together. You'll do one with your friend or friends. There's three of you. All right. So it says a 2.07 liter cylinder. So you have to recognize that is a volume. Is it in the right unit? Yep. Has to be in liters. We are good. Cylinder contains 2.88 moles. So there's your N. We're good there too. Moles is the right thing. At 22.8 degrees Celsius. There's your temperature. What do we have to do to our Celsius? Change it to Kelvin. You don't have to show me the addition. I'm trusting you all can add. Add your 273.15 and it's 295.95, which would round to 296.0 Kelvin. We have N, we have V, we have T. You always know R. So it says, what is the pressure? So we are looking for P in atmospheres. So we definitely want to know what pressure unit we want when we're solving. All right. Here's your equation for the day. P times V equals N times R times T. Plug in what we know. We don't know P, so we'll call it P, or X if you want to solve for X. I don't really care. Your volume is 2.07 liters. N is 2.88 moles. And then you get to R. And again, R has two choices and two choices only. All right. We want atmospheres. So you just need to make sure you pick the one that goes with atmospheres. And that's the little number. So 0.08206. And again, don't memorize it. It's on the back of your periodic table. And again, you don't have to write units. The one time I won't make you. But technically, it's a combination of all of the units. And the units are on the back of your periodic table if you do want to write them. And then we'll plug in T. So 296.0. And then you solve. All right. And you again have to figure out what works for you. I don't know if you're somebody that wants to multiply the three numbers on the right and write that number down and then do your division, I don't know if you're good at just multiplying and dividing all at once. You decide. Everybody's a little different on their algebra. I don't care how you get from showing your work to your answer. You show what you need to show, right? This one, you just divide by the 2.07, so multiply and then divide. And you should get like 33 point something. The answer is 0.79. If we look back, our volume has 3 sig figs, our moles have 3 sig figs, R and our temperature both have 4. We'll just keep 3. So it should be 33.8 ATM. And if you are someone who's struggling with getting the answers, that you're like, I have the work in the right spot, but I'm not getting the right answer, please just come see me. We'll figure out what algebra works for you. And we tend to think all back to like algebra 1 in junior high, but it's just a matter of like what makes sense plus you for you. Yeah. Everyone's at a different spot. All right, questions on that one? We'll make it a little harder. Next one. So again, I like to read a label. So it says a tank has a pressure of 3,800 mmHg. There's your P. And a volume of 11.1 liters. And that is the correct unit. It has to be in liters. Do a unit check as you're working through the problem. At 24.7 degrees Celsius. What do I have to do to Celsius? Oh yes, Ms. McLeod, add 273.15. And even though you don't have to memorize it, most of you probably will by the end of this. I got 297.85. We can only keep it to the 10th, so 297.9 Kelvin. So we have P, we have V, we have T. You always know R. So it says how many grams of helium are present in the tank. Okay. So when we're looking at the ideal gas law, it's not grams that we can calculate. What can we calculate? What does the N stand for? Turn to your table and whisper, what does the N stand for? Moles, all right? But if we can solve for moles, hopefully we all know moles and grams relate to each other. So the equation is going to allow us to find moles, and then we'll be able to go back to old stuff and turn it into grams. So we know P is 3,800 mmHg. We know V is 11.1 liters. It didn't give us N. You always know R, just a matter of which R do we want. Since our pressure is in millimeters of mercury, you want the one that goes with millimeters of mercury. That's the 62.36 number. And then our temperature is 297.9 Kelvin. So we're going to solve for N. This is one where, again, you have to figure out algebra-wise what works for you. All right, so what I would say most of you are going to do, probably multiply these two, write it down, multiply these two, write it down, and then divide, or do it all at once. But again, you have to figure that out, right? I don't care how much work you show between plugging the numbers in and getting your answer. You don't have to show me anything short of what numbers did you put where and what did you calculate. But if you need to, then show it. I do 3,800 times 11.1, and then I hit divide 62.36, divide 297.9. Depends on how you want to type it in. But you should get 2.2705. And our pressure only has 2, so we'll keep only 2 significant figures. So 2.3 moles is what we're going to solve. Okay. So N is always going to come out in moles, or it's going to be turned in, like you have to put it in moles. And absolutely has to be moles. If it wants grams, because again, like in a lab, we typically care about the mass of things. We'll take our moles of helium, and now we can turn it into grams. Where do you find the grams for something? Periodic table. Helium is 4.00. And that should work out to be 9.2 grams of helium would be inside this particular tank. So the hardest part of this equation is just you've got to be very, very well aware of your units. Again, pressure can be either ATM or mmHg, but volume has to be liters. N has to be moles. T has to be Kelvin. Okay. So you're gonna turn to your friends. And I don't know what we did yesterday. Is that what I did alphabet yesterday? All right, whoever's got the next birthday is team leader, go. Whoever's got the next birthday, team leader. And, or if there's the two of you, you can just go together. Walk them through, help each other, talk it out, go. Yeah. What do you want? Sure, I'll look it up. That's the hardest thing with these is like which way. When you're solving for N or T, those will be annoying ones to solve for.
Thank you.
Think about units. This is very important on this one. I think I make you think about all of your units this time. It's 1,000.
It's 1,000, right?
Yeah, no leaders divide by 1,000.
Okay, it's a. Wait, pause, would you?
Really think about what units every letter has to be in for this equation. We ready for our Latin test tomorrow?
No.
No, I'm not even trying on it.
I know, I saw it on a screen this morning when I was down the visit.
7,000.
We did a practice test, I gotta think about it.
Well, like, what do you have to get to do well?
Like how.
No. But it doesn't matter, right?
It doesn't. It's not.
Alright, so like,
Yes, and I got.
got your stuff done this morning, Anna?
Yeah. and then you divide it.
And divided by two.
What?
Did you actually enjoy, did you actually get Starbucks while you were there?
I got Starbucks this morning.
Me too.
Okay, what is?
Wait, maybe it's you, maybe it's you.
I got the last.
Okay, you know.
So
Okay, when you get your final.
What do you want, Celsius or Kelvin?
I got 17.
Yes, you have to pick the right R for the pressure unit. So whatever your pressure is in decides what your R is.
Oh, okay.
So yeah, whatever your pressure unit is, look for that R. It's a matching game for the R's. I got 745 Kelvin and then 472 Celsius. I'm very confident in the answer too.
Yeah, see, I'm not wrong. That's what I'm saying.
Wait, did you divide the right direction?
Can you check my? Work?
I'm
Can you check my work? I got some, it's you, Link.
Yeah, I got one.
What'd you put in for your moles? .0051.
I got some, I feel like that's like, she did it, right? Am I tripping? Cause that's what I got it. And she got it like that times.
Well, she added in an extra 0.
Yeah, it was.
What did I do?
You just can't copy a number down.
Yeah.
Like your answer is 0.32, but you wrote 0.032.
Oh, so I was doing it right?
Yeah, you just randomly put in an extra 0 for some reason. Yeah, I'll probably work up. We're gonna walk through it. I mean, I would never.
Wait, let me retry.
That's what I do. I multiply the 2 and then just divide by each of them.
I just put it in parentheses like that. I just.
Parentheses thing in my calculator, I just hit divide.
Isn't that what we do with like,
4.
dimensional analysis?
I don't. I just hit divide, anything on the bottom is divide, so anything on the bottom, I hit divide in front of it. So I would do 455 times 0.525, divide 0.00514, divide 62.36. The zeros at the start aren't significant.
Got it.
So like, that's
So
like
that
one.
would change it.
That's what, yes, it does. But yeah, it can make it, because even last spell, when someone just did 0.0051, they got like 761 or 751. Did you do 0.0051 for your moles? That's why. 745. So the 0.226 has 3 significant figures, so you'd be 0.00514. And that's why you're off just a little bit. But it's fine.
Wait, is it 2?
What the what? That's why you're off a little. And it does make a big difference on some of these, yeah. Some of these calculations, it does make a significant difference.
The only word for this is 6 things.
Yeah, I'm less picky on this unit, like the temperature sig fig, like when you go to subtract, I'm less picky. Like, although this one you should have found the 745 should not, like, the moles, we should have been okay to do 3 sig figs, but we've been doing that for a while.
Okay, on the, so we just at 1 and for the gas loss, we didn't do it through cement.
The combined, yeah, that's fine. You're gonna finish it on Friday, when I'm not here. I won't be here Friday. We'll come back to it, I promise,
All right.
because we're gonna use it next week.
You have the lab tour.
Yeah, we do, we're gonna pop popcorn tomorrow,
We get time to do our things.
on Friday too. Well, we will, when we have 2 more little things to do, and then yes, on the back. No, you can't get the popcorn. All right, so on this one, I think I heard most of you walk yourselves through it and we've all fixed our little errors, but you had grams, it has to be moles. So grams indirectly is a way of giving you moles. Turn your grams into moles before you plug it in. Yes, it should be 0.00514 for 3 significant figures. Your volume is 525 milliliters, but it has to be in liters, so 0.525 liters. You don't have to show me the math for that. And then your pressure is your pressure. And then we'll solve for T. And again, you have to figure out algebra wise what's going to work for you. If you're struggling, come to me and I'll figure out and help you. Like, how should I solve this? I heard Avery say it. I multiply and then divide. But it's like I multiply the left 2 numbers, and then technically the ones on the right would end up on the bottom of the left if I showed my work. And again, for me, everything on the bottom is division. So I would divide by 0.00514, divide by 62.36. But you can also combine them and then divide. It's really up to you. Really. But always go back and check your work. I mean, that's the one thing you can do is plug it back in and see if it actually works out the way you're supposed to work out for your answer. We didn't do an example of solving for volume, but I think you're capable of it. But you can solve for any of the 4 so long as you have the other 3. All right. Last thing with this, and some of you will like it and some of you won't, and you can actually solve all of these problems, this next 2, with PV equals energy if you want, or you can do it this way. This was a little bit faster if you're someone that likes conversions and can remember numbers, but you can decide. We talked the other day that chemists have what we call standard conditions. That's what STP stands for. So remember, that's standard temperature and pressure. And that is so we can compare gases. Like, it's hard to compare them when there's 4 different measurements that you're like looking at. So if we have a standard, like kind of like room conditions, standard room pressure, standard room temperature, it makes it easier to compare from one lab to another when we're doing our calculations, right? So what this is gonna lead us into is that if you are at standard conditions, we have what we call molar volume. And unexcitingly, that is just the volume of one mole. Call it molar volume. And it doesn't matter what gas you have, every single gas. If you are at STP, 1 mole is always gonna occupy 22.4 liters. If you have half a mole, it's gonna occupy 11.2 liters. If you have 2 moles, it's gonna occupy 22.8 liters. And our last lab for this unit, the big lab we kind of do, is gonna try and prove this number. You're gonna try and calculate this number based on how much hydrogen gas you produce in a reaction. All right, so we're gonna try and prove this number and show that 1 mole is 22.4 liters. If you're at standard conditions. It's gonna let us do 2 conversions. So we can say that 1 mole of any gas is 22.4 liters. Or we can say if I have 22.4 liters, I know that there's 1 mole of a gas there. Now, the trick is it's only true at STP. All right, so with these problems, as you're reading it, if it does say at STP, then we can use this conversion. If it doesn't say at STP, then you have to do PV equals nRT. All right, but for some of you, it'll be a little faster to get to answers because STP does come into play quite a bit in terms of gas problems, just like how we do things. So we'll do one and you'll do one and you guys can start your, see what you said. And you will have time Friday to work on it when I'm not here. So it says molar volume, example 1. So it says determine the volume in milliliters occupied by 8 grams of neon gas at STP. So when you see that phrase in a problem, you can in your head go, oh, that means 1 mole is 22.4 liters. Okay. Now, this problem you could solve with the equation, like you perfectly can, it's fine. You can plug into PV equals nRT. Pressure would be 1 atmosphere. Temperature would be 273.15 Kelvin. Those are standard temperatures and pressures. And then you can use the grams to find moles. Right? You have to find grams to moles anyway, but what I like to do, if I'm at standard conditions, I'll take my grams and I'll turn it into moles. Which you have to do either way you do this problem. Like both of them are going to require you to do this conversion. Okay? So you could stop, find moles like you just did with your friends in the last problem, plug in moles, plug in temperature, plug in pressure, solve for V. You can do PV equals nRT, it's fine. All right? Or because you're at standard conditions, we can do one quick little conversion and we can say 1 mole of neon is 22.4 liters. Sometimes underneath it, I write myself at STP because it's only true then. If you're at other conditions, it's not true. And that'll give us liters, right? If you type that in real quick, so instead of like stopping and plugging into PV equals nRT, you should get 9.4 liters for sure. I'm doubting myself right now. 3 bells of this and I should know it. 9.4, and then it does say milliliters. How do you take liters to milliliters? Multiply by 1,000. And you never have to show me that if you don't want to. I don't care if you show me it or not. You can just do it like I just did there. All right. So instead of stopping getting moles, plugging into PV equals nRT, if you are at STP, you can do a quick little conversion and turn moles into liters or liters into moles. But again, only if you're at STP. So turn to your friends, pick a team leader. I don't care who your team leader is. Do the next one. Try it this way. You should get 50.0 grams. Go.